Hello again. Welcome to my Week 2 presentation. Here is a list of materials I used to complete this experiment. First, we will start by creating solution A. I took 2 1000 mg vitamin C tablets and crushed them into smaller pieces with a fork to help them dissolve faster in water. Next, I added the powder into the beaker along with water and stirred the solution together. You can see the solution is colored and not transparent, so I filtered the solution to help with this. Here is me filtering the solution. After filtering the solution, you can see the solution is not fully clear and does have some coloration, but it did improve a lot compared to its previous state. Now we will take a break and move on to creating solution B. First, I created a foil plate and weighed the plate, which was 0.9 grams, and from there I added and took away cornstarch until I had 0.4 grams, which means a total of 1.3 grams. I then added the cornstarch along with water to the container. There you can see me flicking it to make sure I get it all out. The solution was also cloudy, so I put the container in the microwave to heat the water. And I ended up microwaving it for 2 minutes and 30 seconds, and as you can see in the pictures, the solution cleared up quite a bit. Here's the solution before being heated in the microwave. Here is it halfway through, and here it is at the end of 2 minutes and 30 seconds in the microwave. And you can see the difference, especially between the initial and the end results. Next, I added the hydrogen peroxide to the solution and stirred it together. So here you can see me filling up the beaker to 100 milliliters and then adding it into the solution, and then repeating that step but only adding 50 milliliters and adding it to the solution. Now we're moving back to solution A, where I added the iodine to the solution, and you can see the color of the iodine disappear as I pour it in, which is pretty neat. Making sure I got all of it out. And finally, I added and stirred the two solutions together and waited for the reaction to occur. Funny enough though, as I was recording the solution, waiting for the reaction, I ran out of storage on my phone and it ended my recording, and of course moments later the reaction occurred. So luckily I still had some leftover solutions of A and B, so I was able to record the reaction with my mom's phone. So let's take a look. And just speed up the video. First reaction is going to occur in the beaker. It was interesting in that the beaker compared to the large container I had, as in the beaker you saw it kind of rise up slowly from the bottom, where when I did it in the large container it was more uniform, like as you can see what will happen in this container. Let me just skip ahead. So what is exactly happening? Well, this reaction is an example of chemical reaction rates, or simply put, reaction kinetics. In this demonstration, you can see the reaction rate of the solution by how long it takes for the color to change from clear to blue. Reaction rate can be defined as how fast a reaction occurs. Reaction rate can vary based on the idea of collision theory. Collision theory involves the rate of the reaction being proportional to the collision of the reactants in the mixture. Just as the name implies, it is the colliding of atoms. An important factor of this is that the orientation and the energy between the collisions matter in order for the reaction to occur. As you can see in this picture, the orientation matters, as two oxygen atoms will not have a reaction, versus when you have a carbon and an oxygen atom colliding together, they do have a reaction and form a CO2 formation. Factors that can affect the rate of reaction are concentration and temperature. Typically, the higher the temperature and concentration result in a faster reaction rate. In this exothermic reaction, second-order reactions occur as the hydrogen peroxide breaks down the vitamin C in the solution, which then begins to form I2. This then complexes with the I- in the solution, forming what is called a triiodide complex. Shortly after, this reacts to the cornstarch in the solution, which results in a color change as we see the mixture turn blue. Since I spilled some of my water and cornstarch solution when trying to funnel out insoluble parts, this lowered the concentration of cornstarch, which could have played a role in reducing the reaction rate of the triiodide complex reacting with the cornstarch to turn the mixture blue. I was also 30 milliliters short of iodine needed for this experiment and didn't realize that until as I was doing the experiment. This concludes my presentation. Thank you for your time.